today we're going to do chapter 27, Inference for Regression. So we're going to investigate the association between average monthly temperature in degrees Fahrenheit and electrical usage kilowatts per hour for a home. So this here is information that will be given to you in a problem. Okay, let's first talk about the graphs. This is the graph of the average temp versus kilowatts, and it looks fairly linear. Okay, this is your residuals plot. It's a scattered pattern, doesn't show any pattern whatsoever. And this is a histogram of your residuals. It's a unimodal. And then we have our data here. And then let's talk about what we have. They give us R squared, which is 91.3. Here's our degrees of freedom, which is 10. S, this is the standard deviation of the residuals. So here we have our standard deviation of the residuals. We're going to skip this information here because we don't need to use it in our problem, but we're going to talk about this information down here. Here, this constant coefficient is B1 or BO, your y-intercept. This average temperature is B1, your slope. And here, 4.980 is your standard error of B1. This negative 10.2 is T. And here is your p-value for the problem. It's relatively small. Okay, so for this problem, we could write down an equation for electrical usage using the information here. So we'll go ahead and write that right here. So we would have electrical usage and that would be electrical usage hat equals your y-intercept, which is 3 or 3,898.2 minus, because our slope is negative, 50.9027 times the average temperature. That would be the equation we would use of our line that we have here. And that goes through our data. And we're going to use this information throughout the problem. So you're going to have to refer back to it. So we're going to investigate the association between average temperature and electrical usage. So we need our hypotheses. And for this, we use beta. Okay, I know we've used mu, we've used p, but we're using beta here. So our null hypothesis is beta 1 equals 0. The slope is 0. There is no linear association between average monthly temperature and electrical usage for this home. Our alternative hypothesis, beta 1 doesn't equal 0. There's no linear association between average monthly temperature and electrical usage for this home. Our assumptions and conditions. Linearity. Is the data on the scatter plot straight enough? The scatter plot of this data appears to be reasonably linear. That word reasonable has to be with linear. You can't say just linear. Independence. Are the y values independent of each other? I have no reason to believe that electrical usage for each month are not independent of each other. Equal variance. Are the residuals randomly scattered? The residuals plot indicates that the residuals are randomly scattered. There is no apparent pattern. Normality assumption. Do the errors around the idealized regression line fit a normal model? So we graph the residuals as a histogram or normal probability plot or box plot and assess the normality. So the histogram of the residuals appears to be unimodal and reasonably symmetric. Use the word reasonably there, indicating the residuals are roughly normally distributed. So we just satisfied that assumption. Now we need to name the test, give the test statistic, and the p-value. I will conduct a linear regression t-test with 10 degrees of freedom. My t-value is negative 10.2 because they gave it to us. Our p-value is less than 0.0001. And you could put the statistics in and actually find that, but you can just use the less than 0.0001, but that's the actual value. And our degrees of freedom is 10 because it's n minus 2, which is 12 minus 2, which equals 10. Using a significance level of 0.05, the p-value is less than the alpha level because less than 0.0001 is less than 0.05. I reject the null hypothesis. There's a very strong evidence of a linear association between average monthly temperature and electrical usage for this home. Now we're going to find a confidence interval. This describes the association. So we're going to use a 95% confidence level here. And remember, it's slope plus or minus the critical t-value times the standard error of the slope. So here I have my formula. You must write the formula down, okay? And then you can plug the values in. So something you need to remember, that to get this, my standard error, it's actually negative 50.9027 divided by negative 10.2. Okay, because something you need to remember is that t equals b1 minus 0 all over my standard error of b1. Then I could solve my standard error of b1 to get b1 over t. So if I solve for that, my standard error of b1 would be b1 divided by t. So you go through, you find your confidence interval, and you would say, I am 95% confident that the electrical usage for this home decreases on average between 39.8 and 62 kilowatts an hour for each 1 degree Fahrenheit increase in the average monthly temperature.